Bismillahirrahmanirrahim. Today our lecture number is 2, X-ray diffraction techniques, MS Chemistry, semester 2nd. In this lecture, inshallah, we will discuss about the X-rays, about the diffraction, the X-ray diffraction technique, the theories which are involved in the X-ray diffraction technique, the methods of diffraction, and at the end about the unit cell. X-rays. For the process of diffraction, we need monochromatic X-rays. X-rays are highly energetic and highly penetrating electromagnetic radiations. Monochromatic X-rays mean X-rays of a single wavelength, such as those generated by a copper anode. Here is the difference between the diffraction and scattering. Scattering is the when X-rays are shined onto an object such as liquid, gas, or amorphous solid, just like glass. The radiation is scattered in all directions by the object, as shown in the figure. And what is the diffraction? When the object is a crystal or crystalline solid, the scattering is no longer featureless, but forms sharp spots on a photographic film. The collection of spots is called a diffraction pattern. You know, the diffraction is the property of electromagnetic radiation that causes the radiation to bend as it passes by an edge or through an aperture. Diffraction effect increase as the physical dimension of the aperture approaches the wavelength of the radiation. If the aperture is equal to the wavelength of radiation, then diffraction increases. It means narrow the hole, greater will be the diffraction. The atomic planes of a crystal cause an incident beam of X-ray to interfere with one another as they leave the crystal. This is collectively the diffraction. What are the diffraction conditions? Diffracted beams are found to occur when the reflections from planes of atoms interfere constructively, as we have discussed earlier in the lecture number 1. If there would be the constructive interference, then we can find out the planes of atoms which are diffracted. Second one is the path difference is equal to wavelength. And third one, when the total path difference, which would be 2d sine theta, equals to n lambda diffraction occurs. This is actually the Bragg's law. What is X-ray diffraction? We have discussed previous in the lecture. This is the only method to directly determine the structure of crystalline molecules, and we have already discussed that this phenomena is not applicable on the amorphous solids. When the X-ray beam strikes on crystalline material, then the diffracted rays spread in various diffractions. The atomic planes of a crystal cause an incident beam of X-rays to interfere with one another as they leave the crystal. The phenomena is called X-ray diffraction, and the interference should be constructive interference. This is the powerful technique which was employed to determine the long-standing structural problems, and we have discussed about the benzene, insulin, enzymes, viruses as well. Every crystalline substance gives a pattern. The same substance always gives the same pattern, and in a mixture of substances, each produces its pattern independently of others, and we have discussed earlier. Every substance has a fixed structure, and if we obtain the X-ray diffraction pattern, it will always be same, either it is pure or in the mixture form. And we have already discussed the source of rays may be X-rays, and we can also use the neutrons and electrons, which will be discussed later in this lecture. This is on the left top side the diffractometer, which is used to obtain the diffraction pattern. And diffraction may be single crystal X-rays diffraction or powdered diffraction pattern, and inshallah we will discuss in detail. X-ray diffraction dependence means X-rays depends upon the which factors. Because of its dependence on the number of electrons, X-ray diffraction is particularly very sensitive to any electron-rich atoms in a compound. If we are given with a compound, the electron-rich centered in a compound may interfere with the X-rays, and they produce the diffraction pattern, and hence the diffraction pattern depends upon the electron-rich centers. X-ray diffraction by sodium nitrate NaNO3 displays all three nearly isoelectronic atoms similarly, because oxygen, 3 oxygen atoms are isoelectronic. Isoelectronic actually are the species that have same number of electrons or same electronic structure. But for lead hydroxide PbOH twice, the scattering and structural information is dominated by the lead atom, because in the lead it is the electron rich center, and X-rays will interact with the lead, and diffraction pattern is actually dominated by the lead electronic cloud. This is the simple phenomena when X-rays incident on a sample. Some of the light will be scattered and some of the light will be transmitted. They will form two theta and they will interact either destructively or constructively, and this interference will be observed by the X-ray detector, and finally we will obtain the structure lattice. Important about X-ray diffraction. The electron cloud surrounding atoms can act as diffraction gratings and scattering sites for X-rays. We have discussed this in first lecture that the gratings can act as just like the prism. When light pass through gratings or prism, they can be separated into their component lights, and the component light second, this allows determination of solid state structure, and the structure of solid crystalline in nature should be. For example, lattice types and unit cell dimensions are determined by this technique. This technique is also used to determine the structure of molecules also. The scattering of the radiation with wavelength of about 100 picometer from crystals gives rise to diffraction. And this diffraction pattern, the interpretation of the diffraction patterns gives quantitative structural information, and in many cases the complete molecular or ionic structure. Hence, this technique is used for the quantitative structural information of molecules, ionic structures, and also about the crystals. If the sample is a powder, then that X-ray diffraction technique is called powder X-ray diffraction, and it provides the cell constants for the unit cell of the solid. When the sample is a single crystal, the intensities of the diffraction peaks used to identify all atom locations, which gives bond lengths and bond angles. Hence, in powder X-ray diffraction, we obtain cell constants about the for the cell with unit cell of the solid, and in single crystal we obtain location of atoms, bond lengths, and bond angles. Theory of X-ray diffraction. Theory of X-ray diffraction is given by von Lau and Bragg in early 20th century. It was based on the interference phenomena between crystal structures and X-rays. If we consider a parallel beam of X-rays impinging the sample, they will see crystal lattices arranged in planes. Based on the spacing between these planes. At certain angles, the reflected X-rays beam will undergo constructive interference, which can be seen as peaks in the diffraction pattern. These instances will only coincide with when the path difference between X-ray beams is an integral number of wavelengths apart. The diffraction techniques, particularly those using X-rays, are the most important methods available to the inorganic chemist for determination of the structure. Here is the phenomena shown by the X-ray diffraction. Look at these structures. In the early, two light beams, which are X-rays, hit on the two layers of the crystal. These yellow spots show the atoms present in a crystal. Just look, these rays, when hit the plane, we should measure the angle of incidence, and when these rays move after scattering, then the scattered light angle should also be measured. These two angles will be measured, and after scattering, you can look, these rays can interact either constructively or destructively. These rays, when the parallel rays interact with the crystal, and if they move parallel to each other towards the detector, then they will interact as constructively, and if there is the alternative troughs and crest, and if the crest of one wavelength opposes the trough of an other ray, then they will be the destructively, and no diffraction pattern will be observed. This is the constructive interference, because two rays between the two scattered rays, trough of one ray interact with the trough of. Here is the diagram showing the diffraction pattern. Explanation. Diffraction techniques, particularly use X-rays, are most important methods. X-ray diffraction technique has been used to determine the structures 250,000 different substances, including tens of thousands of purely inorganic compounds and many organometallic compounds. On the left side of this diagram, X-ray tube is present, which is the source of X-rays. These X-rays incident on a substrate. When these rays hit the substrate, there are two beams. One is shown by the dotted line and other is shown by the arrow, full line. Dotted line shows the transmitted light, and the full line, which is going towards the detector, shows the scattered light. The diffracted light, which is going toward the detector, and the detector gets that light and identify give the pattern of diffraction, and by using the information given by detector of the diffraction pattern, we can get the structure of that substance. In this diagram of thin film, these lines is shown by the horizontally parallel lines. The different distance between two lines is the D, which is D spacing, and these lines which are aligned horizontally is the atomic planes. What are the advantages of X-ray diffraction? X-ray diffraction methods are non-destructive. It means the sample remains unchanged and may be analyzed further by using a different technique. Actually, non-destructive techniques are those when once the experiment is performed, the sample is not degenerated or remain unchanged. Second, the X-ray diffraction technique is a staple tool for materials identification in material science. This technique is also used to determine the phase assemblage of crystalline materials. For example, like silica SiO2, a number of polymorphs exist including quartz, cristobalite, and tridymite, with XRD being able to distinguish their presence based on the differing crystal structures, despite their common chemical composition. Different diffraction methods which are used for the characterization of the structure of solids may be the types of X-ray technique. First is the X-ray diffraction, the neutron diffraction, and the electron diffraction. In X-ray diffraction, there may be powdered X-ray diffraction and single crystal X-ray diffraction. If there is the powdered X-ray diffraction, the material being studied should be in polycrystalline form, mean in the powder form. And in case of single crystal X-ray diffraction, the sample is a single crystal of dimensions of several tens of micrometers or larger. The unit cell. Unit cell is the basic structure unit of the crystal. A crystal structure is actually defined as a highly ordered, regularly repeating structure at the atomic or molecular level, forming symmetric patterns. And these symmetric patterns or structures are three-dimensional, with the smallest repeating segment being known as the unit cell. Hence, we can define the unit cell as the smallest building block of a crystal, consisting of atoms, ions, or molecules. Those geometric arrangement defines a crystal's characteristic symmetry, and whose repetition in space produces a crystal lattice. The size of the unit cell is dependent on the atoms involved, that is the chemical composition of that compound and the shape of the unit cell, and is thus unique to each phase. This is the molecule which is blue in color on the left side. In the center, this is the unit cell showing the different angles, phases, etc. And these unit cells, after combining with each other on regularly arrangement, they form the crystal lattice. So it is smallest unit into which a crystal structure can be broken down that still retains the properties of the whole structure. It means the properties shown by the crystal are ionic compound, since the unit cell contains all the characteristic properties of that compound, which is made by repeating this unit cell structure. The unit cell contains the maximum symmetry that uniquely define the crystal structure. And you should also keep in mind that the unit cell might contain more than one molecule. It is not necessary to contain a single molecule in a single unit cell. There may be more than one molecules or atoms or ions in a single unit cell. For example, the quartz unit cell contains 3 complete molecules of SiO2 silica. The crystal system describes the shape of the unit cell. Let's look. On the right side, it is the unit cell, and it contains different crystallographic planes, 3 A, B, C, and 3 angles, alpha, beta, gamma. And on the left side, it is the crystal lattice, which is made by combining the unit cell. The crystal system describes the shape of the unit cell. The lattice parameters describe the size of the unit cell. The unit cell repeats in all dimensions to fill space and produce the macroscopic grains or crystals of the. Thank you. Inshallah, we will be in the next lecture. Allah Hafiz.